Okay, I'm showing you guys another example of polynomial division, and I'm going to show you using synthetic division and long division. I'm also showing you this example because the last few examples we looked at, you saw that it went from x4 to x3 to x squared. So here you actually have some exponents that are not in order. So you actually have to have some basically placeholders, we could call them, or fillers, or we have to represent the x3 and then x. So if I were running synthetic division, again, looking at this, if this is a factor x minus 5, you know that x is going to equal a 5, so we're going to divide by a 5. Now, I have a 3 for my x4. I don't have an x3, so I'm just going to represent it with a 0. I do have a x squared going in degree order, so I'll represent it as a negative 84. And then again, I don't have an x or x to the first, so I'm going to use a 0 basically as a placeholder, and then I have a 225. Now again, first step is always just bringing down this first value, multiplying it by your factor in the box here, 15. Then you evaluate 15 times 5. I would say 10 times 5 is 50, 5 times 5, 25. Put them together, you get 75. Evaluate, and you have a difference in two numbers here. You have a negative and a positive. That gives me a negative 9, which would give me a negative 45. Negative 45, which in the end, 45 times 5, negative 225, and that gets me 0 as a remainder. Now remember, when you write this as a result, there is an x to the third, x squared, x, and then your constant. So basically you're moving down 1 degree. So the answer to this would be 3x squared plus, 3x to the third plus 15x squared minus 9x minus 45. Now here's your result. Yeah, you can factor this with a 3, you could probably factor, but we're just kind of focusing on the division part of it. Now, take a look at this as we go through a long division example. So this is kind of, looks like represents some of the division you saw maybe in grade school when you were dividing a large number. Now again, placeholders are important. So 3x to the fourth minus 0, or we'll say plus 0x to the third, minus 84x squared, plus a placeholder, plus the 225. Now there's a slight wrinkle to this that can get complicated at times, but once you practice a little bit, you'll get used to it. Again, understanding that you know, basically when you divided in the past and you had, let's say, 90 divided by 4, and you said, okay, 2 times 4 is 8, you subtracted what it is that your result was and you got a 10. That's going to be the same thing we're going to do here. And what I want to do is cancel out this 3x to the fourth. I can look at my results from synthetic division just to kind of give me a hint here. And usually what you'll do is, instead of putting what you're multiplying above this first term here, because we're moving back 1 degree, you're going to multiply over this term, 3x to the third. Now what that does is it says, okay, 3x to the third times x is 3x to the fourth, and 3x to the third times negative 5 is negative 15x to the third. Now remember, when we were dividing in the past, you were subtracting. Whatever you multiplied by, you subtracted. So that's going to be the same thing here. You're subtracting this from whatever you have here. So actually this becomes a negative 3x to the fourth, allowing me to cancel out, and this becomes a positive 15x to the third. Now if I evaluate this, this becomes a 15x to the third. And you can see that's kind of matching up with what I have here as far as having a 15. Just kind of keep us on track. Now, I want to eliminate a 15x to the third. So what can I multiply? X times what? Basically looking over here, x times what will give me a negative 15x to the third? Well, I have 15, and I have a basically x to the first here, so I'm just going to multiply this by a 15x squared. And you can see it's matching up with what we have here. And then, so basically I end up with a 15x to the third, and you can see what I actually want to get is something that is the same. I want to get the same value. I'm sorry, we also have to bring down this negative 84 to the x. Alright, same value here. And then 15 times the 5 will give us the positive, or I'm sorry, will give us a negative 75x squared. And again, don't forget, you are subtracting this. Same thing as we were doing here. When you did, again, how many times is 4 going to 10? You said 2. You subtract 8, so there you got your remainder. So basically, you are subtracting whatever it is that you are multiplying these two by. Now, these cancel out. And then this negative actually makes this a positive, and then that's where we get our negative 9x squared, which is similar to what we have here. I want to bring down the 0x. I want to multiply this by, if I want to get rid of this, and this is a negative, I actually want to make it a negative. So I'll multiply this by negative 9x, which matches up what we have here. And this gives me a negative 9x squared plus a 45x. Now I'm going to say it again, and I'll say it all the way till we're finished. You are subtracting this. So this is what's changing your signs. This to a positive, this to a negative. So I end up with a negative 45x here. These are the two that cancel out. This 225 comes down. Now what can I multiply x by to get? I want to get the same thing, because don't forget, when I have the negative out here, it's going to change what it is that I'm saying here. So I'm going to say, okay, I want to make this a negative 45. Negative 45 times x is negative 45x. And negative 45 times negative 5 is a positive 225. Again, I'm subtracting, so the signs change. Eventually, you'll just kind of do this without looking at this parentheses and the negative. This becomes positive. This becomes negative. This cancels out. 225 minus 225 is 0, and we have the same result as we got here, doing it two different ways. And more importantly, this is starting to prep us for if we had a question where you had to divide the 2x minus a 5. Once you add this coefficient here, once you add it, we kind of lose the ability to use synthetic, and we have to start using long division. All right. Now there are ways to get this back to synthetic division, but it is good to know both ways. Questions?
How did you go from 3x to the fourth to 3x to the third, from 15x to the third to 15x squared?
You recorded this, right?
Yeah, that's okay.
Because you're dividing it.
Wait, how did I drop degrees?
Yeah.
Well, I need a 3x to the fourth here, and this is x to the first. So when I multiply 3x to the third times x to the first, that's going to give me, remember I'm adding exponents, that's why we went over all our exponent rules. That's what's going to give me the 1 plus 3, the 4. So each of these degrees have dropped. And anytime you divide x to the fourth, divide by an x, you have dropped a degree. So when you're dividing by an x, this by an x, each of these is going to drop a degree. So that's why I went from 4, 3, 2, 1 to 3, 2, 1 like that.